come back to our next tutorial on how to model a drive shaft. This is again from our project gearbox. The drive shaft is a segmented shaft where we have the first part and then the second step and then the third step. Here we have the mounting of either ball bearing or the sleeve, and then this will be inserted with a keyway, and here we have our hole for a bolt to fix the gear. Alright, now we come to CATIA and go to mechanical design, part design. I name it as a drive shaft. Enter, and we start our first sketch by choosing the YZ plane. So we go back to the drawing. We look at the drawing here. So we have complete shaft like this. So the strategy of creating a 3D model of this sketch is by first create or draw the half part of the sketch only, and leave all the part that can be made during our 3D projection, for example the chamfer, the hole, and also for the keyhole. So what we can do to start with the sketch is we create the half model, half part of the sketch, and then we create the dimension of 35, 55, 145, 58, 36, and lastly the height here 14 divided by 2, 15 divided by 2, 22 divided by 2, 17 divided by 2, 13 divided by 2. Alright, so you can start by using profile, and I start it from 0, 0, so we just sketch a free form sketch like this. So we have 1 step, 2 step, 3 step, 4 step, I think 1, 2, 3 only. Okay, this is too long, but it's okay. You can prepare it back after this, and then connect it back here. Alright, now because we already have this, you can also actually move it a little bit to make it become even logical. So now we have to redimension the drawing. So we start with the full length of this shaft first. So the full length of the shaft will be 145. Then we have to prepare all this dimension, and next we start with 35. I think the strategy should be the height of this shaft first. So we start with this dimension. The height of this dimension will be 13 divided by 2, 13 divided by 2, and then to make it this symmetrical, change it to symmetrical first. Same goes for the other lines, you can do that. And lastly these 2 lines symmetrical. Okay, now we choose this horizontal line, measure it, this 2 line, measure it. We have already this measurement, but it's okay because the measurement is actually different. We have different step here, but it's okay. We go here first, and then we change this dimension to 17 divided by 2. Okay, see, this is constrained together. We can just delete it, and this one will be 15 divided by 2, so we have different dimension there, and this will be 14 divided by 2. So we have this constraint, just delete this. So, and lastly this will be 22 divided by 2. Okay, now next we need to change the dimension of this, which is sorry, just want to make it tidy, and this will be 35, 55, 35, 55. Okay, sorry, should be 55 minus 35, and this will be 58 minus, okay, so we have a constraint over there, you can just delete this, and it should be 58 minus 36, and this is 36. So you can just delete this, 36. So the dimension here should be 145 minus 55 minus 58. How much will we get? 145 minus 55 minus 58 should be 32. So this can be deleted. Alright, so we have here our first sketch, and we can use this sketch to revolute a complete shaft along this line. So we go exit the sketch first, and then we go to use function and change the selection, the axis of rotation to y-axis, and just click OK. So that's it, how we create our first shaft. Next is how to change according to the dimension that we want. So this is the section AA. So we have a hole for our key, and we have also hole for our bolt, and at this edges of our shaft we have a chamfer 1.5 times 30 and 1 times 45. We start with our chamfer first. So the biggest is here, so this one is 1.5. Can start here, select the line here, go chamfer, and 1.5 times 30 degree. So tangent C, we click OK, and then second chamfer will be 1 times 45. Enter. Right. Next, we have here a shaft. We can start by creating a pocket on this surface with the dimension of 5 times 2. The keyhole is above the shaft surface, and we know that the dimension from this surface tangential to the plane that we have created our sketch is 7 mm. So we need to create a plane that is 7 mm above the XY plane. Then by clicking on this plane, we create a sketch, and where we put the oval shape, we can choose it from here, ellipse, or there's another type, elongated hole, and we can use this as our sketch shape. So you just put the point, first point coincident with the vertical line that is parallel to the vertical line here, and then just put it here, and then we can resize it. Okay, So the dimension, this is the radius of this circle. So if we go to this sketch, we have 5, so this one should be 2.5, and the length is 20. So this point and this point, it should be, so you have to click on the center point of the circle and measure it, and this is 20. And then we have to measure the distance between this center line to the end line here. So click on the center line of this circle and click on the last line there. Then we do the measurement. It should be 8 millimeter. And what else that we have over there? So that's it. We can okay, because this line is already coincided with the vertical line. So if we want to change this, we have to check first. Yeah, by pressing Control, click both lines and click on the constraint definition and check whether it is already symmetrical. And it is already symmetrical, we can just exit the sketch. Right, from there we can create pocket, and the depth of pocket will be only 2 millimeter. So change to 2, click OK. So we have finished our keyhole there, and what we need to create now is the hole of this bolt. So because this bolt is a true hole, we don't need to change the plane that we have created for this keyhole, so we just can use back the hole and create a 4 millimeter diameter of hole, a circle, and then the distance between the center line with the line, the last edge here, is 10 millimeter, and then we can exit the sketch and create the hole. So for that we can choose this plane, and by using this hole function, the 4 millimeter, click on positioning sketch, we can reposition this point vertical with this, coincide, okay, and then this point and this line should has a dimension of 10 millimeter. Okay, so we can just finish the sketch, exit the sketch, and we go to up to next, or we can also use up to last. So click OK, and we have created the hole. We have successfully created the hole. So that's all for our sketch. I think there's no other radiuses that we need to do. Yes, just sketch, check back on the sketch. Alright, that's all from the sketch, and we need to assign material. Of course, this is the metal. Click on the part body, choose metal, and choose steel, click OK, and you can look at this construction tree. So everything is already done. We don't need to color the shaft seal, the shaft, because yeah, the shaft should remain in silver color, and we can then save as drive shaft. Thank you for watching, and goodbye.